Going live in 3, 2, 1. If you haven't joined my Discord, you should do so. You can find the link in the video description below if you're watching this on YouTube. If you're not watching this on YouTube, then you can go to my YouTube channel. Where is my YouTube channel? Let's find my YouTube channel. Let's find my YouTube channel. You can see a lot of videos of my dog on my YouTube channel. And this is not my YouTube channel. Some of them are my YouTube channel. So you go to my YouTube channel, and you go to the main page on my YouTube channel. You can subscribe to me. And you can also have a look at the stream. See if I can see the stream. The stream that I'm actually streaming right now. Live. What the fuck? Okay, I forgot to change the title. So, I want to change the title of this stream. This stream is going to be about starting the review of the code. So, let's see. Let's see if this updates. Starting detailed code review of my motor controller firmware. Update all. Does YouTube update? Yeah, cool. That's better. So you can see my stream there, and in the stream description you can follow the link. And no sound, thank you. You can go to Discord here, and if you click on this link, you're gonna get to the chat room that I've set up yesterday, and you can join it. But you're gonna have to. I think you may. What is this? Why is this not working? This was very bad of Discord. If this is not working, why is my invite invalid? Okay, so that link was invalid. I'm gonna create a new link and see if that new link works. Maybe the link becomes invalid if I create a new link. Interesting. Or maybe it's valid for 1 day. This sucks. This really, really sucks. I want to have a link that always works. How do I get a link that always works? Can I just have a link like this? Let's see. Okay. So maybe if you register, you could actually access my channel. What if I have a link that Discord provides? What do I see then? Okay, so this one works. Oh, god damn it. So if the other link doesn't work, then that means that all of the videos that have the other link are not going to have a working Discord link. Fuck! Okay. Damn it. Anyway, I'm gonna update the description of this video, so at least this video is gonna have the correct Discord link. Let's see. Edit video. And let's Interesting, so that was exactly the same link. What link did I have before that was invalid? So if I click on this, oh, that link was invalid. Okay, I see. Right. Okay. So update this to a valid link, and now it should be valid. Is the link valid now? No sound, please. Great. Okay. Is this link valid? This seems to work, at least for now. So I'm going to leave it at that, and I'm going to put this video into the correct playlist. I have a playlist for KiCad motor drive design, which is a playlist for designing a motor drive, a double motor drive using STM32. Can have a look at that one. And let's see. Can I actually save this now? It's saved. Hello, ZL2CCO. Who are you? ZL2CCO has arrived. The party is over. Feel free to ask any questions while I do the live stream. That's the whole point of doing live streams, that you can ask questions during the live stream. And I'm going to get started to actually review the code. So for the code review, I think having done the detailed review, the kind of detailed review that I did for the PCB, that was probably the best thing that I've done in this project. I must say that's worth like thousands of dollars and like maybe several months of work that I would have to do if I didn't do that review, because that review going through every single wire. So I made a Python script that exported every single wire, every single connection in the or like I went through every single component on the schematic, and then I went through every single label also, and that revealed so many faults that I would have missed. That if I didn't do that review, I would have had boards that didn't work. So doing that review ensured that I had boards that worked. I'm very happy with how they worked on the first try. It wasn't the board that didn't have any faults. I did have some minor faults, and I had connectors that I placed in opposite places on two different sides of the board. So the connectors on opposite sides of the board, they're actually flipped around. But that's minor. That doesn't really affect the functionality of the board. When it comes to functionality of the board is working perfectly, and I'm very happy about that. And most of that is thanks to the review that I did, which was going in highly detailed review. And I've had some people go like, "Oh, Martin the perfectionist." You can think it's perfectionist. You don't have to do it. Like I'm gonna do that because that saves me a lot of time. So I want to do the same type of review for the code that goes into the firmware. And I have an idea of how to do this, but this is going to involve implementing certain new tools that I currently don't have. But what I want to do is I want to have an overview of all the functions that actually go into the firmware. So I'm not going to be doing a review of every single function in my code base because there is code that doesn't even go into the firmware. So what I'm going to focus on is reviewing the code that actually goes into the firmware, that actually runs on this board and does something on this board. And the way that I want to do that, I think the ultimate way to do that would be to have some tool that can output the checksum of every single function, and that can track functions as they change. So, for example, if I make an update to some function in the firmware, I want to be able to see that function, that function has changed. Now, I don't know really how that is going to work with the compiled code. It could actually be that if the code is, if some part of the code has changed, maybe some instructions that are in a different place in the code would also change because of that. And that would kind of screw up the whole plan of doing it this way. But if I can somehow configure the linker and the compiler to generate the same code for a function, as long as the function doesn't change, regardless of where in the executable the function is placed, then I can have a tool that checksums every single function in the executable and makes a list of them. And then I can see in Git easily like which function has changed, which function needs to be reviewed again later. And then I can go through every single function, and I can review every single function that goes into the firmware. And by doing that, I will probably eliminate 95% of any kind of faults that could occur, which I probably have missed, because when writing code, it's you always miss something. You always miss some little detail that you haven't thought about. It's really important to go back and to review every connection on the PCB board, every function in C code, and just quickly fix any apparent faults that you see. And then you kind of get this big picture of the project where you can see like, okay, if this function returns a certain value, that would obviously lead to some error or some potential error that could cause a crash in the software. And then you just fix that, and you move to the next thing. And you always have this list of things to check in mind, which means that you're focused on actually reviewing the code and not implementing the functionality. I think those are two different stages. You have to first implement the functionality to make sure that it works, and then after that you have to go back and you have to focus on the potential faults that can occur in every piece of code, potential buffer overflows, potential errors in parameters to a function, which is good to add code to check the parameters of the function. And having that focus simplifies the review stage. So I need to have a tool that can checksum every single function in the executable, and then I have to make sure that that is actually a way that would work. So when I compile the executable, I generate a map file. Now the linker in GCC can generate a map file, and that map file contains a lot of information about the symbols of that go into the executable. It contains the size of the variables. So it's not only the functions that I would review, it's also the variables, like the size of the variables. Maybe I have some variable that takes way too much memory and it's not even needed. Then I could remove that from the executable, free up some RAM memory. So things like that are important as well. And maybe some variable isn't even used, but still gets included into the executable because it's referenced somewhere. So let's have a look at the map file and see what the map file gives us, and then maybe I would need to modify some utility like obj dump or something like that, and add the functionality to checksum every single symbol to make sure that we can identify changes to symbols. And we'll see where this leads. Let's see. So the map file is generated in the build there. And then I have this Flambergman project, and let's see, where do I have the map file? I think it's in firmware. Oh, there it is. There it is. That's the map file. So this is the map file generated by the linker. This contains a lot of information, and most of this information is completely irrelevant for what I want to do. Let's see, so it contains all the objects that go into the executable, which is good to know, but useless for what I want to do. And then it has also the, let's see, so what is this first number here? Is this like, why is it always 0? Is it like a flag of some sort? Size, file, common symbol, size. Oh, this is discarded in sections. Okay, so this is cool. This is all the things that the linker discards because of my compiler flags that mandate discarding any code that is not referenced. So unfortunately this doesn't work really well with drivers, so I have to follow a different strategy with drivers, because drivers register themselves, so they're always referenced at some point in the executable. So what I do is I specifically specify which drivers I want to include into the final firmware. So this stuff is discarded, that's why it doesn't have any offset. It has 0 offset. And then there is... so maybe I could use this file and have a utility that uses libelf to just read out the portions of the elf file, or even just the binary file. That could work as well. So let's see here. And now we have the symbols that actually get included. And it actually includes some more information here. So for example, the end of the stack, you can actually see the number that gets assigned to the end of the stack. This is where this is the end of the RAM on the chip. It gets determined by the linker script. And then we have all of this stuff that gets included from libgcc. This is the FPU operations that are part of libgcc for this particular target. So maybe looking at this, I could actually probably just write a Python script or something that looks at this offset and the length of the symbol, and then checksums the contents of the section. That could be a good start. But I'll check farther here. So. The really annoying part here is that the text wraps around. So I wonder if can this be actually printed on the same line for easy processing? Let's see. Oh, this is not really. This is not really the format that I want. I don't like this format. I could still parse it out, but it's a little bit harder. It's a little bit harder than parsing each line, one line at a time. So there's a lot of things that that don't really matter in this file. And then the only reason that I get sections here is because I have the flag to GCC that generates a section for every single function, which also allows to use the GC sections flag in order to discard code that isn't referenced anywhere. Make the firmware smaller. But this is not really this is not an easy output to work with. Maybe there are options that can make this output better, but I think I could use a different utility. Maybe I could use nm, or I can use optdump to actually dump the symbols and to get everything on the same line. So let's do that. Let's see here. Let's use arm non-yavi optdump. And I need to get the symbols, so T, build their firmware, okay, so this is a little bit better. This is actually an output that I could work with very easily. So this is workable. Good. And does this include data as well? Yep. So this is a list of symbols that need to be reviewed. And we can exclude all of this apps stuff. This is just the object files and C files that get included. I wonder what this section actually does. What is this? C switch 47. What the hell is this? Read only data. Okay, so apps seems to be the like something that determines, like that tells you which files get included. Okay, so this actually tells you this is the file and this is the functions that are inside that file. So this kind of follows the same layout everywhere. So we have the MCP 2317 driver and then all of the functions that actually go into the driver. And instances is the array of all of the instances of this driver. And then all of the functions that belong to this driver. So I could actually filter them out. Let's see if I can get some script running in Python to actually read this file and to check some the contents of the binary file. I think that I could actually use the binary file that is generated as part of the compilation process and to read out the data at these offsets. That could work. I'll have to try. Vim, let's use nvim. Mapgen. And by the way, I'm not a very good Python programmer, so I'm going to have to look up a lot of things, like how to do a lot of things in Python. I understand the syntax, but when it comes to APIs, I don't really know so many APIs in Python. So I'm probably going to have to look up everything. Let's have a look at Python split. Read file line by line. Let's do the simple stuff in Python. Read file line by line. This is like the most basic crap you could ever do in Python. Okay, so open, close. How to get a line at a time. Read line. Okay. Yeah, let's start with that. So with let's see, with open. Let's do map test. Or symbols. Symbols. List. As fp, and then we can do line equals read line fp read line, and then we can print the line. And I don't think I need to have anything else here. And this will obviously fail because the file doesn't exist. But I'll create the file by doing this. Let's open a terminal. So I'm going to split this, and I'm going to open the terminal here by just typing edit term and then the command bash. This is the kind of stuff you can do in nvim. You cannot do this in ordinary vim, but in nvim this works fine. And then I will do armnon, so basically the same thing that I did before. Obj dump t, and then line environment firmware src, and we can delete all the abs lines. Let's see. No, little v. That's better. And what is the und? Und is undefined, obviously. Register frame info. Interesting. Where does that come from? Anyway, I'm gonna put this. Let's filter it out. And this will go into symbols LSD. And then Okay. Yeah, using nvim inside tmux is not the easiest thing to do, because now I cannot exit this terminal because I'm in tmux, and in tmux the shortcut that I have for exiting the terminal actually switches me to a different console. How do I exit this now? Maybe I can do like, no? Okay. I can do like this. Yeah. Okay. So I'm gonna quit this and I'm gonna open a new nvim session in a different tab. Without tmux this time. Okay. So running this, yeah, and now I can actually open the terminal again. So term bash, there we go, Python mapgen py. Nothing. I can actually exit this terminal. Okay. What am I doing wrong? Okay, while line strip. Okay. This removes the spaces around the line. Okay, this that didn't work. Okay, yeah. So this is, yeah, this didn't really make sense. So do, can we do while in Python? No? Okay, we cannot do while. That's why they do it this way. Print line strip and then line equals fp read line. I suppose you have to do it like this. Yeah. Okay. A bit better. And now I should split this into a list of fields. Could it be done like this? Maybe. Okay, cool. And then there is a tab actually. Okay. Can I split by tab then? Ah, come on. Okay. Maybe I could do it like this. Replace the tab with a space. Okay, and this would be sent to symbols st, and then with the Python script I should get yeah, I'm going to just update the Python script to to use spaces. Tabs, and then this will be filter lambda x, and this will return if x not equals empty string. Could this work? What is this? This is screwed up. This is really screwed up. Okay, just to keep that command fresh in history, and then I'll run this Python script. Object has no attribute filter. Okay. Let's see. It's probably like filter. Just like a function, yeah. Okay. Fields, filter, line split. Okay. Python filter lambda. Okay. So the other way around. Split. Okay, so I got all the fields. It looks like it's working. And next I have to strip the new line from this, from the last field. So what I could do is map this through, let's see, fields is map lambda x, and then x strip. So now I don't have any new lines on the symbols. But then there is stuff like this, for example, where you have this extra option hidden in front of the symbol. So I'll need to take care of that. Okay, and the symbols of interest would be the symbols that go into the text sections, and also the symbols that are actually included. So anything that has zeros there, for example, let's see. Or actually, this function is included, but for some reason it has zeros there. This is all assembly functions though, so maybe that's why they have 0 length, because it's impossible to tell how long the function is in assembly. So I will just look at the stuff that goes into the text data BSS row data sections, and then anything that's left over I can just review separately, or maybe include at the end. So I'll be back in a bit. Okay. Let's see here. So now I should be able to read out the data from the location specified in the first field. If it's actually located in Flash. So anything that goes into data is just variables that are not initialized. So I will only review the size of these variables. I will not be reviewing the contents. But anything that goes into the code section and is located in Flash, which is basically everything that goes into the code section, those are the methods and symbols that I want to review. So let's see if fields. If 2 equals f, then it's a function. Then we can, let's see, how do I parse a hex number? Okay, that was easy enough. And can I actually do like this in Python? Let's see. Really? List index out of range. Oh, okay. So there are some places where the list will not be more than 2 fields. So if len fields equals 1, 2, 3, 4, 6. So I'll just look at everything that is 6 elements long. And then if that, like this, and then let's see. I could concatenate this actually with 0x. Which could work better. No. Oh, I need to also is this like the base? Let's see if this works. Okay. then Python print. Just hex. Okay. Cool. Right. I think this makes sense. D6 E0. Yeah, so this makes sense. Now I want to look in the binary file and see if I can extract the actual data. And I think okay, what would be the best way to do this? Let's see if it's better with a hex file, because I think that the binary file will actually include I wonder if this offsets are valid for the binary file. If they actually we could check this. So let's see. Let's dump let's dump portions of this of each symbol. So Python read file length offset. Maybe this works like this. Okay, and then I could seek to the offset. So seek binary 6 set and the offset. And the length is 0, 1, 2, 3, 4. Size is better. 4. And this doesn't need to have any mask there. So read count size. Will this work? Sorry, of course, size. Maybe I can just print 10 bytes. Okay. Seek is not defined. Okay. Okay. So this can be 0. That's better. I could convert this to hex maybe. So, format data, format 0 to x, data. Valid conversion. Okay, so format x. For x in data. This is taking a bit longer time than I thought, but yeah, I'm getting somewhere. By the way, I cannot see any comments right now because I'm available on Discord, but I'm not watching the YouTube comment stream. So if you want to comment, then follow the link in the video description and join Discord. Okay. So, what am I doing wrong here? Okay, so if I were to do it this way, I need to include the parentheses. Come on. Seriously. Okay, maybe I can just use bytes. Could I use bytes? This is a binary string. Bin ASCII. Okay. Read hex. Oh, maybe this already returns. Maybe I can just do like this. Read hex. Nope. How about opening this as a binary? Should I be using like with? This is probably the same thing. Okay, this seems to be a little bit better. Okay, finally. So what I'm gonna do now is just dump this symbol. Maybe I could disassemble this. Let's see. Okay. Could disassemble the whole thing and just look at the offset. This doesn't look like the data I'm seeing. Or 4604 F8B5. Oh, actually it is. Yeah, this is the correct data. 0446 OE46. Yeah, so it seems like this is working. So now all I have to do is just create a checksum of this data. Maybe we could use like CRC32 maybe. Let's use CLib. And then do like this. Three, four, five. So 5 is the name. And the offsets are going to change between executables, but the checksums shouldn't. Cool. So I'll do this, and then I'll modify a method. Let's see what method I can modify. I could modify so this would be FB update measurements. Let's build this. It just gave an error because it can't flash because the board is powered off. But the file should be compiled now. Okay, so this I need to generate a new list first. So I'm gonna do it. Like this. And by the way, this is probably something I'm gonna be saving. And do like this. And diff new prep. Let's see what changed. A lot of things changed. So apparently it's not as simple as just doing a checksum. Let's see. Okay. What if I build with position independent code? Yeah, so this should be, this should at least, although yeah, so maybe it's the data offsets that actually get changed. So it's not the code offsets, it's actually the data that screws things up. because it's trying, like when functions try to load addresses of absolute, like strings, for example, constant data. If there is if those addresses change, then the checksum of the functions change as well. It's actually fun to check. I'm going to check this. So I'm going to go to the disassembly. They're identical. Did I actually compile this? Yeah. So this is the stuff that actually gets changed when I just add that single line to print something. So it's yeah. So all of the references to print k actually change because that extra string offsets all of the other variables and the code as well. So it's calling the absolute address. Okay, so maybe I can get rid of this at least with position independent code. It's still worth trying, I think. So I'm going to add a new GCC flag. I'm going to do the same test again. So in, and then, no, not here, main here. I don't actually need that. And then I will move the file so to this as old. And now I can recompile this. And then run the script again. And then fire up meld. So how different is this from the previous picture? Yeah, it's still pretty different. Okay. But on the other hand, also for the most part, it's just the branch instructions that get different values. Okay, this one is actually completely different. Okay, this was actually not achieving the kind of result that I wanted. But it was still interesting to try and see if this is actually a viable, a possible solution. But it doesn't really produce the results I wanted. So maybe I'll just go after the size. So if size changes, then I do a new review of that function. Yeah, well, that's much simpler. So let's see. I could have done this with just a bash command. Got it. Oh, of course. String. So old, and then I'll remove that code and build this again. All right, so this is at least a hint of what has changed. So this is a possible way moving forward. And then I could just review all of the symbols, and I could, when it's time to do a new review, I could just review the ones that have changed. And sometimes, of course, there is a slight chance that after a change, the symbol will have exactly the same size. But I think that in conjunction with Git history, it's still possible to look up the symbols that need to be reviewed again for a new version of the software. Alright, so I'm gonna sort this by size, or maybe I should sort this by name actually, because the functions that have the same name, they're going to be in the same file, so it's easier to review that way. But I could have a look at the sizes as well, but that would be a separate task. So I'm going to sort this by, okay, there's no need for this Python script anymore. But I could still use the Python script, because in the Python script I can easily just choose the symbols that are functions, for example. So I'll do like this. So this would be mapgen, and then we can sort this by name. So that's it. That sorts it by name. Cool. And some of the functions I don't need to review. For example, the free artist stuff. That's the stuff that I just assume to work because it's part of free artist release. And it's also the code that I don't fully understand anyway. But all of the code that is part of the rest of the software, and which is not part of the GCC libraries, that's the code that I'm going to be reviewing. Is it possible to dump the debugging information? Maybe I can actually filter out the stuff that's part of the libgcc. That would make things easier for me. Can I do list source file? Another thing I could do is actually, if I can find some utility that can actually read the C code and create a checksum of the symbol. So I would look at the symbols that go into the executable, and then I would look up those symbols in the code base and automatically just generate a checksum of that symbol. Then I could check if that particular function has changed. But then going from the source instead of looking at the final executable, which we have found out changes in considerable ways when only adding a single line of code. So let's see. Yeah, this is useless information. What about line numbers? Maybe line numbers could help. source. Okay. This gives a full disassembly, which is not what I'm looking for. Okay, about file headers. Can be bothered to look up what each symbol means. So maybe I just check this. No, this was useless as well. What I would like to get is actually the line number of the file and line number of each symbol. That would be useful. Oh, cool. So we can actually dump global symbols as well. Interesting. Let's see how many bugs I have in my software. Every single global symbol is a bug, according to me. Let's see. So, can I get the symbols here? And that's so if it's not a if it's not a function, and let's see, so if fields 2 not f and fields 1 equals g. Let's see, that's not many global symbols. I have the device tree, the analog ops, regmap ops, which is actually, those ones, they should be static in the file where they're defined. So this is something I need to fix. F-delete version impure pointer, C-type pointer, blah blah blah. All of this, like this stuff is okay to be global, to have as global symbols. But yeah, all of this stuff is either from, this one is from libfdt, and this is from the C library, and this as well. And current TCB, that's the current task that's being executed, and opt-in is for the argument parsing. Erno is also global. But beyond that, okay, and Q registry. But beyond that, I'm pretty happy. I almost don't have any global symbols. Like, I definitely don't use global variables in my C files. Besides the device tree, but I could make that local as well. The device tree kind of needs to be referenced globally. All right. So, let's find this analog ops and regmap ops, which is not defined as static. So let's see. Yep. Okay, I don't think that works. It doesn't work when executing the command from Vim. Okay, so we have static, 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 static. No, this is, let's see, where is the, yeah, here. Static, static, static. Where's the one that is not static? Struct, here. So let's see, LP55231. I should have it also here. Yeah, there it is. So this one is supposed to be static, because it's not supposed to be accessible from outside of this file. And the other one was, let's see, the regmap ops. And do the same thing for the regmap. And that was easy to find. This is the one. This is the offender. Good. All right, so I'm ready to create a Git hook that will actually run whenever creating a tag and prevent creation of tags unless every single symbol has been reviewed. I'm going to write a small file that is going to execute the necessary commands first. So this script is going to this will run as part of the make process. So actually what I could do, file, right? Okay. So I will have something like this. And what else could I have any use for? Maybe the data. Actually, I could probably just remove the offset of the symbol and keep all of the other fields, and just have that sort of and just have everything in the same file besides the global symbols. Global symbols are good to have in a separate file. Actually, this will be global data, because there are many more global functions, but global data should be kept to the minimum. Global data. All right. So let's see what this produces. And also, oh, okay. So I'll just remove the first field. This will be open for writing. And I need to do fields 12 maybe. almost there. Okay, so actually pop the back of the list, which is not desirable. I want to pop the front of the list. Pop 0, maybe? Or is this? Yeah. Let's see. Okay, much better. It would kind of make sense to also sort them by by the name. So I'm gonna go ahead and do that. Or could I just yeah. Maybe I can just print this. Interesting. Let's see if we can import tabulate. And then so global list push. And then sort. What is this? Oh, I'm not really sure. Section size name. All symbols, the all list, and the only thing left is to sort them. Okay. From operator import item getter. Now wait a minute. So this will actually be 5 or 4 in this case. 0, 1, 2, 3, 4. Yeah, name should be 4. Global data. Let's see how this works. Invalid syntax. I missed one of the parentheses. No module name tablet pip. Control D. Okay. I'm going to try installing Python tabulate from apt. List object has no attribute push. Oh, of course. This needs to be a list. Okay. And then let's have a look. Alright, so now it's sorted. So this is a good start. I could probably use this for doing the review. Because as I will be doing the review, I will actually be modifying symbols, which will modify this table. But hopefully only the sizes will change. Great. So I'm going to add this file to Git, and every time I do a review, I can check, or every time I change some code and I want to do a new review, I can check the differences between this file and the version in Git. So that's it for this video. This is the starting point of doing my detailed review of every single function in this firmware. Great. Thanks for watching. Bye.